Hello and welcome back to my Allen Bradley PLC test bench. Today we're going to be testing the 1771 OFE2. This is a 4-channel 4 to 20 milliamp output module. The 4 channels on this are tied into our 4 test meters, and we're also going to be using the FLUKE 771 Process Clamp test meter. This shows us our 0 to 20 milliamps. So this is actually going to show us not only the module, but how to use the FLUKE 771. So we'll get swung around here and go to our next scene, which is the card, the programming, and the output, and how we test them. So back in a minute. Alright, so here's our 1771 OFE2 module. And as you can see, we have the green light on, which is always a good situation to have. We have our 4 channels wired up. And we zoom in a little more. And as you can see, this is 8 wires. The bottom 2 terminals on the WC, which is the gold-plated wiring arm for analog, are empty. And these wires go over to our test board, which we'll show you here in a second. So we'll go into the programming here next and be right back. Okay, really quick on the programming for this module. All we've done is an auto setup using the channel configuration. Go in there, the I/O configuration, we pick our chassis, we inserted our module, which is the OFE2B. It automatically, when you tell it to, it automatically picks, and then when you go into the setup screen, you can see at the top here that it says insert ladder rungs. And again, this is straightforward, simple, basic, and it's exactly the way the manufacturer has decided to do it. For data format, we're using 2's complementary binary. Our raw minimum is 0, our raw maximum 4095. And currently our data is sitting at 2048, which is about in the middle of our range. We close it here. In this rung, all we're doing is taking our first word, moving it into our other 3. So if we put in 0, in theory we should have 4 milliamps. If we put in 4095, we should have 20 milliamps. Now every card is going to be slightly different, and that's the whole reason for doing the testing. So we'll swing over here to the test board where we're tied into, and using the 771 we'll see what kind of results we get. Right back. Okay, so here's our meter, and being an old analog meter, you have to look at it and you got to be close to see what's going on. So again, we're set at 4095. Go to 0, and we go to 4 milliamps. Now, is that 4 milliamps? We don't know. If we go to 2048, it takes us up to 12 milliamps. But that's by our load meter. You know, how accurate is that compared to today's digital meters? So what we're going to do now is we're going to take our clamp off of here, and we're going to start confirming with our 771 FLUKE meter what we're getting. So we're just going to change setup here a little bit and right back. Okay, so here we are. We've got the 771 hooked up and sitting here, but we haven't got the clamp on. So we take that, and as you can't really see there, but there's an arrow on it, shows direction of current flow. In DC, that's always important. Now if you look at the meter, it currently says minus 0.23. So the first thing you have to do is zero the meter, because you're looking for accuracy. Put it on, you close it, remove your hand, and we're at 3.99, now we're at 4 milliamps. So that channel is highly accurate at this point. Now we go to 2048, 11.96, and we go 4095 and 19.92. So as you can see, as we get to the higher end on this channel, you can see that it gets a little bit low. We'll go back to 0 again. We're 4. Now what you need to do with your testing is go back and forth a few times, let it sit for a while, try it again. You're looking for consistency. Now this is just one of the 4 channels. So you have to do this on all 4 to be able to confirm that all 4 of the channels are consistent. Because if you have a system where you need exactly 20 milliamps and you can only get 19.93, you have to do some adjustments. If on the low end you go to 4 milliamps, and here we are at 4.01 bouncing, you could have problems on your low end. So again, analog is never perfect, but you need to know what your ranges are. You can't just say, well, it says it's going to be that. You have to confirm it. So what I'll do before I package this up to send it out to a customer is I'll go through the entire... Light went off. Backlight. There we go. I'll go through each channel individually. Go from 0, 2048, 4095. Record the set, what it gives me, what I was expecting to get. And I'll do that for each channel. That way, when I send this out to you as a customer, you know what you're going to see the test sheet and know exactly what you're getting for your money. So anyhow, that's how I test an OFE2 4 to 20 milliamp analog output module. Thanks a lot. Subscribe anytime and come on back. Thank you.